Hello everybody and welcome to Uplift Education's first ever virtual unit preview for chemistry. My name is Michael Brinkman and I am the Secondary Science Curriculum Coordinator for Uplift, and I will be your tour guide for Unit 1. I am pleased at this time though to announce that Ashley Doherty has joined the Uplift family as a chemistry teacher and is our new chemistry CTL. She's joining us after earning her stripes in the Dallas ISD. And she will most likely be much more enjoyable to listen to throughout the year than me. If, in some cataclysm, all of scientific knowledge were to be destroyed, and only one sentence passed on to the next generation of creatures, what statement would contain the most information in the fewest words? I believe it is the atomic hypothesis, or the atomic factor, or whatever you wish to call it, that all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. In that one sentence, you will see there is an enormous amount of information about the world if just a little imagination and thinking are applied. I believe at the heart of this study of chemistry is this quote from Richard Feynman. In conveying this to scholars, you set a tone that we are going to spend a year thinking and talking and discovering about really tiny particles that you will never see with your own eyes. But through this work, we will learn a whole lot about what underlies everything that we do see with our own two eyes. The first unit is about understanding the atomic model and how it came to be. Specifically, how things can change over time when evidence presents itself, when conditions change showing us something we have never seen before, or when models start to come up short. The statement of inquiry states, as humans and civilization advance and make new discoveries, once accepted models used to explain the world around us change based on that new evidence and or conditions that are present in this world. Every good science classroom is driven forward by the questions that are being asked. In a MYP science classroom, the debatable questions should be generated based upon the statement of inquiry. Next, you ask yourself, what concepts must a scholar know in order to engage in the debates? And then what are the questions that drive scholars to that conceptual understanding? Then, one would ask themselves, what facts must a scholar know in order to understand the concepts? And what questions would drive scholars to that factual knowledge? In this way, you backwards design the inquiry questions that are going to drive your unit to that statement of inquiry. And in an ideal world, a science classroom is driven by questions or a few questions every single day, not necessarily by objective statements. And scholars are provided experiences, from demonstrations to labs to hands-on activities to even readings that would allow them to discover the answers to those questions throughout the course of instruction. On the unit plan, you will see just one example of how these questions can be scaffolded for this unit. So there are two content standards that are embedded within this unit, and I want to take some time to look at those. So we'll start with Chemistry 6A, understanding the design and conclusions used in the development of the modern atomic theory. The second understanding, electron arrangement, and expressing that electron arrangement through the Lewis valence electron dot structures. So two things I want to mention. First, what scholars should know and were tested on by Starr in 8th grade, which is the atomic structure and determining proton, neutron, and electron numbers. Also, a familiarity with the Bohr model was required for those students in 8th grade. The second point is that 6A isn't a history standard, who did what and when kind of thing, but it's truly understanding the experimental design, the experimental results, and the conclusions to get an idea of this thinking. I really want to look at the MYP-aligned unit assessment at this time. So the first question on the unit assessment, and there are three of them, really probes a scholar's understanding of atomic models beyond that simple explanation from 8th grade. This includes understanding the Pauli exclusion principle and how orbitals are shaped by the probability distributions necessitated by the Heisenberg uncertainty principle. At this point, I would like to encourage you to pause this video and quickly look at the rest of the unit assessment. For returning teachers, you may notice this is a very different unit assessment compared to what has been provided before. And the short answer is that Uplift Education is an IB network, but I think the longer answer is these scholars will take a DP science course in which their success will be largely based on 3 papers or exams that are taken at the end of the second year of that course. While the first paper is a multiple choice, it counts for 20% of their total. The second paper is short answer with 2 essays or long answers, and the third paper is short answer with 1 essay. And so implementing IB-aligned unit assessments in the MYP begins to prepare scholars for success in their DP science classes. While we're talking about assessments, I wanted to bring your attention to the constructed response that is on CA1. This question is aligned to this unit, and it requires scholars to have a deep understanding of the gold foil experiment and its implications on the atomic model. At this point, again, I would ask you to pause and look through Common Assessment 1, because the unit assessment in Common Assessment 1 should really serve as your guideposts as to what you're going to cover in the course of this unit and to what level it needs to be covered so that the scholars can then be successful on those assessment items. Again, as you do this, keep that IB lens in your mind that models change over time as new evidence becomes available. In addition to providing you a stage or an MYP Criterion A unit assessment, we also provide you with a unit performance task. And so this unit performance task has 2 purposes in Unit 1. The first is it allows you to establish your lab report guidelines. Whatever your format may be, I would encourage you to think about how that format can be assessed utilizing the MYP criteria. If you do not have a format, or you are not really happy with the one you have been using, then I would encourage you to look at the MYP Science Inquiry Guide located in the Curriculum Documents tab on your Blackboard course page. The second purpose is to allow scholars to interact and manipulate the variables involved in the light scattering experiment that just happens to be the constructed response for CA1. Before you plan out your unit, I encourage you to play around with this PhET simulation and see where it can fit in. The MYP rubric provided to assess the lab report is tailored to criteria B, C, and D, but there's always room to add at least 1 strand from criteria A, which is really the 1 strand that holds scholars accountable to the content. In the context of the statement of inquiry, scholars need to explore how this experiment led to change in the atomic model. Please take some time to explore this PhET simulation and think about how you could fit this into your unit. As we move into stage 3 of the unit plan, there are just a couple of pieces that I want to draw your attention to in this virtual unit preview. The first is the Learning Experiences and Teaching Strategies box. So the common theme really running through this box is that teaching strategies that have analogies and visualizations and ideas that allow scholars to see with their eyes and touch with their hands, those things that they're being asked to manipulate in their head on the unit exam and the CA, are things that should be done frequently and often within the classroom. We're asking at this point for young adolescent scholars who have limited prefrontal cortex connection going on. We know this brain behavior, we understand this biology, but we're asking them to not just think in the abstract, but manipulate in the abstract. And that's really at the heart of what makes chemistry such a difficult course. So the more we can do these things, we put it in front of them where they can see it and touch it and feel it and maybe even waft it, the better they're going to be and the better the outcomes will be for the whole. The second thing I really want to bring to your attention is how well this unit actually aligns with chapters 4 and 5 in your chemistry textbook, and that there's a number of resources that have been listed within this stage 3 that reflect this alignment. Also, towards the bottom here you see that besides the Rutherford experiment, there are 2 additional PhET simulations that are listed. If you were one of those overachievers, you could certainly look at all three of these PhET simulations, and given you're writing just one lab report, maybe think about how all three of those could be combined into that particular performance. Lastly, I wanted to give you kind of a general layout of the 6 days in this unit. From having scholars think about what constitutes good experimental design on day 1, then walking through the development of the atomic model on days 2, 3, and 4, and finally finishing up with a deeper look at electrons and electron orbitals on days 5 and 6. Again, this whole unit is about studying something that is really small, and the more you make it visible, the more you make it hands-on or interactive, the better that your scholars will understand this topic. Thank you so much for your attention and for listening and for following along in this fabulous virtual unit preview. It's great. It's really great. If you have any more questions, though, please reach out to Ashley Doherty or myself, Michael Brinkman, at our email. If it's really urgent and you like talking to somebody and not reading something, then by all means, give me a phone call. My phone number is listed, and I will get back to you as soon as I can. Thank you so much. Have a great start to your year, and I'm very excited about seeing everybody at Collaboration Day kickoff.